In section 6.3, we're going to be looking at some inverse trig functions. And in previous sections, we evaluated the functions at various angles, but at times we need to know what angle would yield a specific sine, cosine, or tangent value. So for this, we need some inverse functions. And if you recall from previous knowledge, previous sections, to have an inverse, a function must be 1-to-1. So to be a function, you have to pass the vertical line test. To be 1-to-1, you have to pass the horizontal line test. Basically saying that each x goes to one y. So your x's are not repeating and your y's are not repeating. So the problem with our trig functions are that they're not 1-to-1. So what do? Well, we are going to work to restrict the domain. So we are going to restrict the domain, and we're going to restrict it in such a way to make it 1-to-1. And so we're going to cut it down into a certain area so that we pass that vertical line test and that horizontal line test. So let's notice some similarities here. With your sine function, we're going to restrict it between negative pi over 2 and positive pi over 2 because sine is a cyclic function, that curve continues on and on. We're just going to cut out this piece here so that we get one part of that curve so that we pass the vertical line test and we pass the horizontal line test. With cosine, we're going to switch it over and restrict it between 0 and pi. And again, we're just going to get this piece of the curve. Tangent, we're going to be between negative pi over 2 and pi over 2. And that's just one of the curve between those two vertical asymptotes that it has. Doing this, we can then take these three functions, well, we can take all six, but we can take these three functions and we can actually look at their inverses. Now, the whole reason we want these inverses because back to our basic operations, if we have multiplication, its inverse operation is division. If we have addition, its inverse operation is subtraction. So if we have a function of sine, cosine, or tangent, we need some kind of inverse operation in order to cancel it out in order to solve for some specific values. And so here's the first one we're going to look at. This is the inverse of sine. You can see that it does have this little -1 right here. If you remember when we were working with inverses, we had f of x, and then the inverse would be f with a small little -1 up here of x, and that just signified that you had an inverse. It was a notation. It was not an operation. It was not like a squared or a 1/2 that we were trying to cancel. It was just notation to show that we had an inverse. So, and that's why you see these little notations of the -1s on these next three trig functions. Now, what we call this is we also call this arc sine of x. And so you'll see either of these two notations, but they mean exactly the same. Now the bottom typed one is what you're going to see on your calculator or on the on-screen calculator, but in your problems you could see arc sine or sine to the -1 like this. Now they do say arc sine when you're reading it verbally, but this does not mean 1 over sine x like when you're working with your negative exponents. Typically when we have a sign in there, say we had sine squared x, we do like to put exponents right here. But in the case of inverses and this little -1, this does not mean 1 over sine x. So do not try to switch it around. It is an arc sine, and if it makes you feel more comfortable and less likely to manipulate it incorrectly, then write arc sine, ARC, before it. Now, what does this arc sine function look like? Well, if you go back to your basis of inverses and you switch every x and y, you can see that this is a function that is now between -1 and 1, and you can see that its y values are also going to be based off of pi over 2 and negative pi over 2. So literally switching every x and y, we receive this graph here. The same is true for arc cosine. We could write it as arc cosine of x. Excuse me, I got a little too many x's going on there. And again, this is the inverse function of cosine. You can see its graph is the inverted of it. And then this is considered your arc tangent. You can see that its curve has been switched out. And so when we're working with these arc functions, if we are taking Up here, we would have y equal to, say, sine of theta. And so we were taking sine of an angle. Well, now when we switch it around, it is the angle that we are looking for. And so you might even change your thinking and say, which angle equals the coordinate. And so just like when you worked with inverses, you had to switch your x and y, you got to switch these around, but we're switching angles with coordinates. So you really got to check your mindset here and make sure you're in the right way. So the first thing that we're going to do is we are going to look at evaluating these, and because I want you to understand what is going on. And as always with anything in these chapters here at the end of the course, a picture is going to help you as you go. So with this, you can see I want to evaluate all these functions. And so when you are evaluating them, things to remember, you want to be thinking where or which angle does, and so for this one, the first one, which angle does sine of theta equal 1/2? Because this here is our coordinate, because we inverted it, we're trying to find the angle. And so if I'm trying to find which angle does sine theta equal 1/2? Well, let's think about this. Sine, if you're thinking about your coordinate pairs, it's cosine and then sine. So if I draw a quick little angle here, if sine is my y value and sine is 1/2, that means it has to be either in this quadrant or it has to be in this quadrant, because that's where sine is positive. Again, thinking about the signs here, this would be, it would be positive in those top two quadrants. And so I'm going to say, okay, where does sine of theta equal 1/2? And we would say when theta is equal to, and then we're going to find those two values in your trig circle. So I'm going to find this angle here that would have that 1/2, and that would be at pi over 6. And then I also want to find the angle over here in the second quadrant. That would be that. And if I go from here all the way over, this would be at pi over 6 and 5 pi over 6. But remember that your arc sine of your function is restricted, because of this restricted domains, between negative pi over 2 and pi over 2. And so if it's restricted between these two values, this is not in my restriction area. And so then I would be able to clearly say that arc sine of 1/2 is equal to pi over 6. So you really got to think about a lot of components here. Not only do you need to remember your restrictions from the first page, but you also need to be going back to your unit circle in order to pick up what quadrant it is in and what angle has that value. Now you can see pi over 6 is the exact value. We're not going to be using our calculators to find these. I should expect you to see pictures and finding out what's going on from there. So let's go ahead and look at the next one and figure out if we can figure this one out following those same steps. And so I'm going to go ahead and draw where I think my angle is. Looking at the fact that we know our ordered pairs are cosine and then sine. That means this being an arc sine, this is the coordinates of sine, and it's negative, so it's going to be dropped down into the quadrant 3 or quadrant 4. I also need it to be at the square root of 2 over 2, and from your unit circle, we know that dropping down this way would give us arc sine of negative square root of 2 over 2 to be equal to negative pi over 4, or if we were to go this way and pick up this angle, that would be at 5 pi over 4. But again, based off of these restrictions, this would not be the answer because of the restricted domain on the original function. And so you can see how knowing your restricted domain from the first page, and then also knowing your unit circle and knowing where your sine is, this is going to help you to figure these out. Let's move on to some cosine ones and see what we can do with those. So we're looking at arc cosine of negative square root of 3 over 2. So again, knowing that it's cosine comma sine, it's going to be my x, and I need x to be negative, which would be in one of these two quadrants. And again, going back to my unit circle, I would say, okay, where is negative square root of 3 over 2? That would be either be at 5 pi over 6 or 7 pi over 6. But remember, your arc cosine is restricted between 0 and pi. So this would not be the solution. So this would be equal to 5 pi over 6. Do you see how you kind of got to work it backwards and think about what do you know and how could you get there? Let's move on to arc tangents. And so say we had arc tangent of 1. Okay, so let's kind of think about what we know. So we know tangent of theta is equal to 1 because we're trying to find theta, our angle, and we know it's equal to 1. We know this is true when, think about your tangent, always go back to kind of your basic building blocks of sines and cosines when you need help. So if this is equal to 1, that means that they had to have the same value. So that would be at square root of 2 over 2, because it's at the same angle, over square root of 2 over 2, or it would be at negative square root of 2 over negative square root of 2 over 2. So where does that occur? Draw a picture. That occurs here when we are at pi over 4. That occurs here at 5 pi over 4. But remember, tangent of theta is restricted to negative pi over 2 comma pi over 2. So this would not be in the domain of what we're working with. So then our answer is just going to be pi over 4. So you really cannot forget anything as you're going. You got to build upon previous knowledge, and we're going to be putting it all to here to analyze it. Now let's look at the next one. We're looking at arc sine of 2. Now this one does not exist. Why does this one not exist? That is because if we're thinking about sine of an angle being equal to 2, because that's our quadrant, think about your unit circle. Our unit circle is only 1 unit wide. It's not going to get to be 2. So this is never going to be true. So this does not exist. Now, when we get into some of these arc functions and we're dealing with things off of our unit circle, we have to go to a calculator with these. But you can see in the previous ones, I would not be going to the calculator to show full work. I would need to see the picture, figuring this out, because I want exact values of pi over 6, negative pi over 4, 5 pi over 6, and your calculator does not output those pi values. So for arc sine of these coordinates that are not on my unit circle, we are going to have to go to our calculator. So when you go to your calculator, you're going to be using that arc sine function. This gives you approximately 1.325 radians, or if your calculator switch over to degrees, 75.93 degrees. So make sure you understand what the question is asking it in, radians or degrees. Make sure your calculator is in that. Grab the calculator you're used to using, the on-screen calculator or your handheld calculator. Make sure you recognize the buttons. You can input it right now and get the same values as me so that you can figure out what steps you're missing. So when you get to an unknown value on the homework or exam, you know you're following the correct steps. Then you're going to do arc cosine of negative 0.4. When I punch this one in, again, your button's going to look something like cosine to the negative 1. Again, check if you're in radians or degrees. In radians, you would get 1.982 radians. Or if you were in degrees, you get 113.58 degrees. Be careful with your rounding. Again, make sure you're in the correct unit that the question is asking you for. Now, this was just basics of figuring out what these functions evaluate to do in terms of arc. Let's look at how it's going to benefit us and why we even need to learn these inverse functions. Looking at these two examples here, it says solve the triangle for the angle. So let's think about this. What do we have? We have an angle we're trying to solve for, and we have something adjacent to it, and we have the hypotenuse. And so if you think about SOHCAHTOA, you see that you have adjacent and hypotenuse. So we know that cosine of theta is equal to adjacent over hypotenuse, or equal to, in this case, 9 over 12. So if I wanted to solve for theta, I would say, okay, to get rid of, because I'm trying to get this theta by itself, To get rid of the cosine, I would say arc cosine, and whatever you do to one side, you have to do to both sides. So this would cancel here, and I would have theta equal to arc cosine of 9 over 12. Now 9 over 12 is not on your unit circle, so we would have to use our calculator for this. And this would be theta is equal to 41.41 degrees, or if we're in radians, approximately 0.723 radians. And so knowing these inverse functions help us to take a side angle side triangle and solve for that given angle. And then, of course, we could find, this is a right triangle, so we could find the other side, and we could find the third angle knowing all this. But this kind of helps us out in the solving. Now, this next one, what we're going to have to do is we're going to have to work from the inside out. We want to evaluate arc sine of cosine of 13 pi over 6. And so to evaluate something like this, you're going to work from the inside out. First, we're going to figure out what is cosine of 13 pi over 6. Based off that result, we'll be able to do arc sine to figure out the angle that we want. So first, we're going to do this inside part. So number one, I want to figure out what is cosine of 13 pi over 6. Well, this is equal to cosine of, if I break it apart, 12 pi over 6 plus pi over 6. And so then from there, we can think about this. Okay, well, 12 pi over 6 is just 2 pi. And so if I draw this out, that means I would go all the way around. That would be my 2 pi or 12 pi over 6. And then I would come up a little bit more so that I'm looking at this angle here of pi over 6. The coordinate for that angle is square root of 3 over 2. You can see how important knowing your trig circle is. So therefore, what is cosine of pi over 6? Because that 12 pi over 6, again, just gave me a rotation. That would be equal to square root of 3 over 2. So now, step 2, I'm looking at the arc function of square root of 3 over 2. Well, remember, square root of 3 over 2 of your sine, draw a picture. Here's here's your angle. And so right here, this is where I have square root of 3 over 2, looking at my trig circle, and that angle is at pi over 3. And so it's kind of a puzzle to figure out, but the best advice I can give you is start from the inside, work your way out, draw pictures, use your unit circle, and those are going to be your best guides. And as always, don't forget your restricted domain. So this next example, I want to do it because we do need to consider our restrictions on our domain in order to work it. And so again, first thing I'm going to do is I'm going to work from the inside and then work out. So I'm going to do this first. So number one, I want to figure out what is the arc function of 4/5. So let's consider this. Arc function of 4/5. I need to figure out the cosine of 4 over 5, and then I need to switch over to the sine of it. And so what I'm going to do is I'm going to approach this a little bit differently. I'm going to do this using the Pythagorean identity. In using a Pythagorean identity, I know that cosine squared of theta plus sine squared of theta is equal to 1. And I know that cosine, so if this is equal to theta, this tells me cosine of theta is equal to that 4/5. So in this case, I know cosine squared of theta is 4/5. And I'm only left with sine. So solving this out, this gives me 16 over 25 plus sine squared theta equal to 1. I'm going to subtract that 16 over 25, so it gives me sine squared theta equal to, let's see, that would be 1 minus 16 over 25. And so if I get common denominators, that would be 25 over 25 minus 16 over 25. That would result in sine squared theta equal to 9 over 25. And then remember, the little negative 1 tells me it's an arc function or an inverse function, but this square tells me it's the whole thing being squared. So I can square root to get sine. And that gives me sine of theta equal to the square root of 9 over 25 is plus or minus 3/5. But we know that the arc function is restricted between 0 and pi. So if it's between 0 and pi, that means it's got to be in quadrant 1 or 2. So that means sine is only going to be positive because of that restriction. So that tells me sine of theta would be equal to 3/5. So if arc cosine of 4 over 5 gives me theta, and even though I don't know theta, I need to figure out sine of that angle, using my Pythagorean identity helped it to fall out and to get the 3/5 that I was wanting to evaluate this function. So don't feel like you're restricted from using other tools that we have learned through these chapters, because you can see how the Pythagorean identity helped me to get it there. But you've got to understand your inverses and how they work with each other and what information it gives you. Is it giving you the angle or is it giving you the coordinate? Inverse properties that we're going to pick up from this is, let's just kind of take it all the way back to our algebra skills. Recall that f of f inverse is equal to x and f inverse of x is equal to x. When you compose functions together, if they are truly inverses of each other, it outputs just x. And so if we consider our sine function, first of all, we have to remember our restrictions. That sine is restricted between -1 and 1, and on the y's between -pi/2 and pi/2. So sine of arc sine of x would cancel each other just to give you x. Likewise, arc sine of sine y would cancel each other just to give you y. And then the same is going to be true for your cosine, and the same is going to be true for your tangent. So knowing these capabilities, helps you to see that doing tangent of arctangent of 5 just output -5. If I go to arc sine of 5 pi over 3, that just outputs 5 pi over 3. But sine is restricted between pi over 2 and -pi over 2 and pi over 2. So I need to find that alternate coterminal angle. So if this is 5 pi over 3, then the alternate coterminal angle would be -pi over 3. And that would be the correct answer for this because of the restricted domain. So you really need to maybe grab a Post-it note and have those restricted domains handy as you work through these inverse functions. Now putting all this together, so these are some kind of quick ones. We've worked with triangles, we've worked with alternating, a sine and arc tangent, etc. Let's go into some modeling or some of our application problems here. So modeling with inverse trig functions. An airplane needs to fly to an airfield located 300 miles east and 200 miles north of its current location. At what heading should the airplane fly? In other words, if we ignore air resistance or wind speed, how many degrees north of east should the airplane fly? I'm a math person. When I see a lot of words that's like English, I have to revert back to pictures and just pull out data. And so I'm going to draw a picture because I do better with pictures and formulas, not all these words. And so if an airplane needs to fly to an airfield located 300 miles east, so I'm going to remember north, south, east, west. And then I'm going to figure out from here, if I go 300 miles east, that means I'm going to have 300 miles right here moving east. Here's my airplane. If I move this way, I'm going east. And then 200 miles north, so now I'm going to go up. So there's 200 miles north of its current location. This was its current location. So this is my angle. So I've created a triangle out of this. We're kind of in a triangle chapter here. So looking at what I have, from my angle, I have opposite and adjacent. So that's going to signal that I want to do tangent of theta equal to 200 over 300. And I know I want to do tangent because if you think of toa, tangent is your opposite over adjacent. And so that gives me tangent of theta equal to 2 over 3. And then based off our arc functions now, you can do arctangent of both sides in order to solve this. So it gives me theta equal to arctangent of 2/3. And so if I run to my calculator and I type in arctangent of 2/3, it says how many degrees. So I'm going to make sure my calculator is in degrees, and I get a value of 33.69 degrees north of east. And so if I took all these words away and only gave you a triangle, then I think you would probably get there a little bit quicker. So if you have a paragraph like this, start drawing a picture of what this depicts. Figure out, what do I know? What can I work with? Manipulate it. All this is going to help you to get to the conclusion of the answer, but also possibly get you maybe partial credit in an exam situation. Let's look at example 8. OSHA's safety regulations require that the base of a ladder be placed 1 foot from the wall for every 4 foot of ladder length. Find the angle such a ladder forms with the ground. Again, I'm going to need a picture for this. And so here's a wall. Beautiful picture here. Here's my ladder. And it says that the base of a ladder is to be placed 1 foot from the wall. So say that's supposed to be 1 foot for every 4 foot of ladder length. So say if that were 4 foot. Now, if it's a 4 foot ladder, I probably I'm not going very high up. Like maybe it's way higher up. I'm trying to clean a really tall window in a business. Well, we need to make this in a larger situation. So let's just draw the triangle it creates, and let's call this X. If this feet away is X, then this is going to mean that my ladder is 4 times that X. And it wants me to know the angle the ladder forms with the ground, so I'm looking for theta. So again, consider what sides of the triangle you have. You have an adjacent and you have a hypotenuse. And so that means I want to use cosine for this. Oops, excuse me, jumping all over the place here. So I'm going to say cosine of theta is equal to x over 4x, and that reduces to 1/4. So if I say cosine of theta is equal to 1/4, now because of my arc functions, I can arc cosine both sides. And that's going to give me theta equal to arc cosine of 1/4. I go to my calculator and I type that in, and that gives me approximately 75.52 degrees. And so again, use a picture to kind of help you out with this. Speaking of that, I want to end this lecture with one more video. I know it's been kind of a longer lecture. In a video game design, a map shows the location of other characters relative to the player, who is situated at the origin, the direction they are facing. A character currently shows on the map at coordinates -3, 5. If the player rotates counterclockwise by 20 degrees, then the object in the map will correspondingly rotate 20 degrees clockwise. Find the new coordinates of the character. Woo! I don't play video games, but I'm a little lost right now. So let's kind of figure out what's going on from here. So it says, if a video game design, a map shows the location of other characters relative to the player who's at the origin. So I'm right here at the origin, and it shows people relative to me. The direction they are facing. A character currently shows on the map who is at coordinates -3, 5. And so that's this point right here. And if the player rotates counterclockwise by 20 degrees, then the objects in the map will correspondingly rotate 20 degrees. Find the new coordinates of the character. So basically, I'm kind of spinning, and so my map is changing. And so here's what we need to figure out. First, we want to find the radius of the circle. And so what we did was, here's us at the origin, here's the other player, we've created a circle. And so first let's find the radius of this circle and the original angle. And so we're trying to find this original angle right here before we start rotating around. And so you can see that our radius of the circle will go from here to here. And so I can use just Pythagorean theorem to kind of figure this out, because we know this is -3 and we know this is 5. And so I'm going to say negative 3 squared plus 5 squared gives me my radius squared. So that's 9 plus 25. Sorry, I should have had that parentheses right there. Equal to r squared. So that gives me 34 equal to r squared. So r is equal to the square root of 34. You can see it's very shy of that ordered, so I couldn't just count it over this way. So the exact radius of this was square root of 34. So if I want to figure out the cosine of theta is equal to negative 3 over square root of 34, knowing my newfound information of square root of 34, I can figure out this angle to be using my arc functions. Theta is equal to the arc function of negative 3 over square root of 34. Typing that in my calculator, I get theta to be equal to 120.96 degrees. So now we are going to rotate 20 degrees clockwise. And so I will take 120.96 minus that 20 degrees, so I'm at 100.96. And so then if I want to figure out these coordinates, I need to figure out my cosine and my sine. So step 4, I'm going to say x is equal to r cosine theta. And we know that to be the square root of 34. That's why I needed that radius. Cosine of my angle, 100.96. And so x would be at negative 1.1086. And then if you do your y value, y is equal to r sine of theta. That gives me square root of 34 sine of your angle. And then that gives you your y value to be at 5.7246. So this example really puts a whole lot together. Not only did we have to find our radius, we had to use these values here from previous sections of figuring out your x value, your y value. We now are able to use our arc function, and we're able to take something and rotate it in order to find this new coordinate. And so this example really puts a lot together. Hopefully the previous stuff was flowing very nicely for you, and so this kind of encapsulates this. But if you need any more help along the way, please reach out through Canvas messaging.